Hello everyone, my name is Ashwar Shajapurkar. I am pursuing my engineering degree from IPS College, Indore. On this platform, me and my team, Abhinandan Chauhan, Abhishek Potfode, Anurag Verma, Ayush Raghuvanshi and Kalpit Sahu are going to present our project on topic Safety in Bulk Storage of Petroleum Products under the guidance of Mr. Gaurav Anthony Sir, Assistant Professor, Fire Technology and Safety Department. Contents of this project include introduction, in which hazardous material and its classification, class 3 flammable liquids and combustible liquids, literature review, area of study, in which storage tanks, firefighting foam and foam delivery system, problem formulation, in which type of fire anticipated and its causes, and at last references. Introduction of this project is going to be explained by me, literature review by Anurag Verma, area of study in which storage tank will be explained by Abhinandan Chauhan, firefighting foam will be explained by Kalpit Sahu, foam delivery system by Ayush Raghuvanshi, problem formulation and references will be explained by Abhishek Potfode. Now let's start with introduction. Hazardous material. Hazardous material are the objects which pose any potential to harm the environment, humans, animals around it, either directly or indirectly. Classification of hazardous material. The most worldwide accepted classification of hazardous material include 9 classes. Class 1 explosive, class 2 gases, class 3 flammable liquids and combustible liquids, class 4 flammable solids, class 5 oxidizing substances and organic peroxides, class 6 toxic substances and infectious substances, class 7 includes radioactive materials, class 8 includes corrosive substances and class 9 includes miscellaneous substances. This project is mainly focused on the storage of class 3 substances, that is flammable liquids and combustible liquids. Now this category is divided into two divisions, that includes class 3.1, that is flammable liquids, which are liquids with flash point below 60 degrees Celsius, and class 3.2, that includes combustible liquids which have flash point above 60 degrees Celsius.
Hello everyone, my name is Anurag Verma and I am going to talk about the literature review of our project. The first literature review was given by H. Pretrell, W. Lee Sox and Ordonin in 2013. They contributed the experimental determination of the heat release rate of hydrocarbon pool fire based on oxygen consumption and carbon dioxide generation. They presented the chemical methods for the experimental determination of heat. The second was given by Chen Lin and Hui Fang Wang in 2011. They studied that to avoid tank fire or explosion incidents spreading to the neighborhood areas and evacuated people, it is essential to keep safe distance between storage tank and nearby areas. They did it by a fire dynamic simulator. It is computerly simulated, which simulates flammable liquids storage tank for spot the fire numerical simulation to detect a fire to happen. The second review was given by Ibrahim M. Sloff, Salim A. Abdullah in 2010. They did research on boilover, which is considered as one of the most dangerous fire in large scale fire. Boilover is nothing but basically when uh, where water is having high density than most of the flammable liquids, so it settles down in tanks, and after a certain temperature it boils and creates huge explosion, because when water molecule expand into 1700 times of its volume. So they conducted an experiment and models to understand how to control boilover phenomena. The paper also presented boilover experiment study in ADCO's JD's terminal. Here ADCO is Abu Dhabi company for onshore oil operation. The fourth review was given by Sir Thomas Steinhaus and Richard Carwell in 2007. They focused on burning behavior of large pool fires and fuel spill fire and give details of pool fire dynamics and considered factors which affect the pool fire. A series of well-defined parameters have been established to classify pool fire in quantitative manner. The research clearly show that despite of enormous body of work on large-scale pool fire, there are still significant uncertainties in our capability to predict the behavior of such fire. Thank you.
Good morning, friends. My name is Abhinandan Chauhan, and now comes the area of study, in which our first part is storage tank. Storage tanks are the containers that hold organic liquid, non-organic liquid, compressed gases, and petroleum products. Storage tank can be widely seen in petrochemical industries, oil refineries, etc. Storage tank have different sizes ranging from 8-meter diameter to 90-meter diameter. Storage tanks are often cylindrical in shape, perpendicular to the ground with flat bottom and a fixed or a floating roof. Now let's come to the types of storage tank. As we know that there are 4 types of storage tank which can be clearly seen on a screen. They are: first, open top tank; second, floating roof tank, which are subdivided as external floating and internal floating roof tank. Now third one is fixed roof tank, which is subdivided as cone roof, dome roof and internal floating roof tank. Now the fourth type of tank is other tanks, which include bullet tank, bolted tank and spear tank. Now let's talk about the fixed cum floating roof tank. It is the safest storage tank which is used for the storage of petroleum products of class A and class B. These tank have a fixed roof over a floating roof. They are used for the products having very stringent water content specification like aviation, turbine fuel and products sensitive to oxygen like light intermediate feed tanks. Another type of storage tank used for the storage of petroleum products are floating roof tank. The floating roof tank is the most widely used storage method to safely control product evaporative emissions from volatile petroleum products. They are subdivided into 2 categories, which are external floating and internal floating roof tank. These both type of tanks are used for the storage of highly volatile substance like naphtha, xylene, fluorine, etc. Now let's talk about the external floating roof tank. In external floating roof tank, the roof is not attached to the tank. Roof floats on the top of the liquid. It reduces the loss of liquid by minimizing evaporation. Floating roof comprised of fittings, deck and rim seal system. Horton sphere is the another type of storage tank which is used for the storage of liquefied gases, and the dome roof, which is the type of fixed roof system, is used for the lighter material whose vapor density lies in between 0.85 to 1.06 kg per centimeter square.
Hello everyone, I am Kalpit Sahu. I want to talk about types of foam. Types of foam. Foam are basically used in firefighting system. Foam consists of tiny water and gas bubbles. There are 2 types of foam in general use: mechanical foam compound, chemical foam compound. These foam are provided first mechanical foam compound. These foam are provided by air interpretation by mechanical means such as aspiration or air blowing. Mechanical foam compound again classified into 3 types depending on the expansion ratio of the compound: low expansion ratio, medium expansion ratio, high expansion ratio. Low expansion of these foam compounds up to 20 times foam compound. Medium expansion foam, these foam compound can expand up to 200 times their volume and are generally produced by self-aspirating foam branch pipe with net. High expansion foam, these foam compound have an expansion of up to 1000 times their volume and generally produced by foam generator using air fans. Second, chemical foam. Chemical foam is generated by chemical reaction. The most common ingredient used for chemical foam are sodium bicarbonate and aluminum sulfate with added stabilizer. Classification of foam by composition. First, protein based foam. These are made from hydrolyzed protein with added stabilizer and preservatives. They form a thick foam blanket and is suitable for hydrocarbon liquid fires but cannot be used on water miscible liquid. Their effectiveness is limited on low flash point fuel which have lengthy pre-burn time. Second, fluoroprotein foam. Fluoroprotein foam contain added fluorochemical which increase its effectiveness which have a lengthy pre-burn times. Third, synthetic foam. Synthetic foam concentrate is based on the foaming agent, then hydrolyzed protein, and including aqueous fill foaming foam concentrate, medium and high expansion foam generator. Fourth is aqueous fill foaming foam, AFFF. These foam compound consist of fluorocarbon sulfate, a foaming agent, a stabilizer, used in many areas. Multi-purpose aqueous fill foaming foam. These are synthetic foam liquid designed for fire protection of water soluble solvent and water insoluble hydrocarbon liquid and can also be all types of water. all types of water. Sixth, fill foaming foam. This is combination of AFFF and fluoroprotein foam and thereby provides a high level of knockdown effect and post fire security and burn back resistant. Thank you.
Hello everyone, this is Ayush Raghuvanshi. Today I am discussing about conveying system. Conveying system are of all outlet types in which foam discharge from all outlet at the same time and covering all the hazards. And conveying system consisting of water supply and foam concentrates, proportionator, piping system and etc. And today and conveying system are of three types which are as follow. First is fixed foam conveying system, second is semi-fixed foam conveying system, and another is, which is last, is mobile conveying system. Now I am coming to the first type, which is fixed foam conveying system, in which fixed piping are being used to supply water at adequate pressure, and foam concentrate, tank, educator and proportionator are being used to discharge to make a foam solution. And this system also may use detection system to activate the system. Now I come into the second type, which is semi fixed foam conveying system, which is used to get supply foam concentrate through mobile foam tender, and a fixed piping connected to the foam makers come vapor seal box in case of cone roof tank, and foam pourer in case of floating roof tanks convey foam to surface of per tank. Now I am coming to the third top type, which is mobile system. It includes foam producing unit mounted on a wheels, which may be self-propelled or towable by a vehicle. These units supply foam through monitors and foam towers to the burning surface. Thank you.
Hello everyone, I am Abhishek Portfole and I am going to talk about the types of fire anticipated in storage tanks. Now, Number one is overfill ground fires. Now, overfill ground fires or type fires result from piping or tank leakage. Many times, they are the result of another cause, such as operator error or equipment malfunction, and are considered the least severe type of incident. If a leak occurs without ignition, exercise caution and isolate all ignition sources. If ignition does occur, then simply treat such a fire as large pool fire. Now, we have vent fires. Vent fires are typically associated with fixed roof tanks such as cone or internal floating roof tanks. The main cause is a lightning strike that ignites 32 vapors which may be present in the vent. This is a less severe type of fire and can be usually extinguished with a dry chemical powder. Then we have rinsill fires. Now, rinsill fires comprise of a large majority of fires in the external floating roof tanks, but can occur in internal floating roof tanks as well. With as many tank fires, lightning is the primary cause of ignition. Although with floating roof tanks, an induced electrical charge without a direct lightning hit may occur. Because these fires are the most common, there is usually a high rate of successful extinguishment, assuming that there is no collateral damage, such as pontoon explosion failure. Now we have obstructed full liquid surface fires. Now, obstructed full liquid surface fires can occur in fixed cone roof tanks. They tend to be challenging because the roof or pan blocks access to the burning surface. The roof or pan can sink for various reasons, such as an increase in vapor pressure under an internal floating roof, which can cause the pan to tilt. The pontoon failure of external floating roofs is commonly caused by closed drain walls during rains or mechanical seal failure, causing the pan to sink. Then we have unobstructed full liquid surface fires. Unobstructed full liquid surface fires are relatively easy to extinguish when the tank diameter is relatively small, that is less than 150 feet, and sufficient resources and trained personnel are available. The most challenging fires will involve larger tanks, that is greater than 150 feet in diameter. Because of the surface area of the fire and the amount of resources needed to control and extinguish the fire, unobstructed full surface can occur in fixed roof tanks without internal roofs, where the fragile weak seam of the roof shell joint separates as a result of the explosion or an overpressure event, leaving a full surface tank. Now, let us talk about some causes. Now, it can be caused due to some operational errors, that is, during the operation, if an error occurs, then it can lead to a fire. Also, a fire hazard can occur if the equipment or the instrument undergoes a failure. Now, one of the most important causes that are often overlooked are static electricity. Now, it can also lead to fire hazard. Now, we also have maintenance errors, right? Then we have tank and piping rupture. Now, due to the increased pressure, the tank and pipe undergoes a rupture, then it may also lead to fire hazard. Then we have supporting system failures. That is the safety systems that are used to tackle the fire hazard. If they undergo failure, then also it may cause a fire hazard. Now, let us talk about some references. We have Department of Transport US. Then we have Emergency Response Guidebook 2012, GSDMA, that is Gujarat State Disaster Management Authority. Then we have IS 10987 1992, reaffirmed 2003. Then we have IS 803 1976, and then we have NFPA 400. So that's it. Thank you.